Atupele, right? Okay. Right. Atupele is going to be taking us through energy efficiency in HVAC system and building management system. Atupele and Kiundu, right?
Kilindu.
Okay. Kilundu.
Kilindu.
Kilindu. Kilindu. And the name of the company is Tido Energy.
Tanzania Industrial Research and Development Organization, TIRDO.
Perfect. Thank you so much. Over to you.
And don't worry, I'm not offended. Thank you all. As she said, my name is Atupele Kilindu. I'm from Tanzania Industrial Research and Development Organization, TIRDO. Today I'll be talking and share to you the concept of energy efficiency in building and TIRDO role in improving energy efficiency in building Tanzania, and as well as our experience in improving energy efficiency in Tanzania. Before I start to share this experience, I want to introduce Mr. Robert Washidya, is my colleague from UNDP. He will introduce a little bit about the project that may impact the stakeholders, building stakeholders in Tanzania, to explain a little bit about what they are currently doing. Mr. Robert? It's not there. Sorry. We can continue. I think you will explain it. Yeah. Can you go to the 10th slide, please? Yeah, Mr. Robert will do later the presentation, so I'll continue. He's not here. So today, as I said, I will talk to you about our experience in improving energy efficiency in buildings. And next. So in the outline, I will talk about the concept of sustainable buildings and what is energy efficiency building and the benefit of having energy efficiency buildings. And I'll explain to you about the factors that may affect energy efficiency in building. Also, how can you identify different options in attaining energy efficiency in building, how to optimize energy use for thermal and visual comfort in buildings, also the way, how go-to way to attain the energy efficient buildings, and I will look last about the case studies of PSSF Tower in Dar es Salaam, how we did an energy audit, energy efficiency assessment there, and how we were able to improve energy efficiency building as a case study. So what are the sustainable building and sustainable building constructions? When you say a sustainable building construction, we look at the environmental perspective. We do construction activities and they look to minimize environment, less or no effect to the environment. So there are 7 pillars that you can attain in sustainable building. One of them is energy efficient. So we have a sustainable design, we have a durability, waste reduction, indoor air quality, water conservation, sustainable building materials, as well as energy efficiency. So these are the 7 factors that when you look at them and took into consideration during the building construction, you are going to a sustainable building activity. So energy efficiency, what is it? General energy efficiency is using less energy to perform a particular service or to produce a certain product, or produce more using the same energy, or produce more service using the less energy. So that is energy efficiency. When we look at environmental perspective, or building perspective, we say that we maximize comfort with the least possible energy within a building. So within a building, normally it's about occupants. We are constructing a building, but mainly it's about occupants and the activity that they are doing there. So nature of the building is depending on the particular occupants. So the aim is to have a maximum comfort. So for energy efficiency means we are using less energy to attain that maximum comfort within the buildings. So main focus when we say energy efficient buildings, we say we're using energy. We want to reduce that energy to maintain a particular comfort. So the diagram shows there energy use within a building, so maximum gross energy. So what we need is for an occupant to feel the comfort, but we're reducing the energy use within a building. So what are the benefits? When you are being efficient in using energy in the buildings, you reduce energy use for space heating, cooling, or water heating. These are the most common activities that are used in the building, especially large buildings, such as commercial buildings, hotels, even in households. Also, the benefits you are reducing electricity usage within the building, because we have appliances within the building that are making us comfort and visual and thermal comfort. So when you are reducing energy, you are reducing also the electricity usage. Even the utility, we're using less demand. We're able to attain the demand for a particular users within a country. Another thing is improved comfort. When we're using energy, very useful. That means we can attain a certain comfort within the building, even if the number of occupants are increased or decreased. Also, for the equipment that are used within the buildings, we'll have lower maintenance activities within the building. The last one is it enhances property value within a building. For some certain countries, when you are being efficient and you go as far as to have ratings, building ratings, energy performance certifications in the buildings, it enhances your property value. It increases the value even if someone is come to rent something, because they know your energy, your building is performing very well at a certain level. Next. Then we are going to look at the factors affecting building energy efficiency. One of the factors, like I say, is demand. A hotel usually is different from a hospital, and it's different from a household. So, for example, in hospital, the hospital is performing 24 hours, but the school is performing its office is performing from morning to evening. So the demand in the hotel is different from a school. So this is one of the factors that affect energy efficiency. Another one is the efficiency of the equipment. We can look at how efficient is equipment, but also the operating efficiency. If your efficiency is very low, it may affect your energy consumption. And also if you're operating your equipment at low efficiency, it affects your consumption. So those are the factors also affecting big energy efficiency. Energy emissions. Well, by assessing that, we can know how to reduce those two factors. Another thing is energy audit. Energy audit is help you. It can help you to prioritize your actions. As you know, where areas are the energy waste, where can I invest in improving my energy? You can prioritize your action on how to improve your energy performance. So energy audit is the first line of actions, one of the first actions normally we do when we want to manage energy within the buildings. But it alone you cannot sustain to manage energy within a building. So systematic approach of energy management is the best way to improve energy performance. Next. So as an energy auditor, what do you do within the buildings? So like I said, you assess the performance of a building. In the building, the appliance used within a building. So a different system. We have heating, ventilation, air conditioning, we have lighting, we have different energy consuming systems. So by fine-tuning, when we want to assess where we can improve our energy performance, you are adjusting the operating parameters to better match demand and supply. So for example, the opportunity of changing the heater settings or AC settings from 24 degrees centigrade, from 21 for example, to 24 degrees centigrade, without affecting the thermal comfort of the occupants here, can you reduce energy consumption? That's called fine-tuning. When you say retrofitting, you say, for example, we have a system here. We have, for example, a cooling system. Including heating, ventilation, air conditioning. We may add a variable speed drive to control the flow of air. That's called retrofitting. We improve the system in order to be more efficient. or waste heat recovery, for example, the boiler. That's called retrofitting. This is one of the ways we can have opportunity for saving within a building. The other one is upgrading. This is you changing the complete system for an efficient system to more energy efficient system. If it's a heating system, you completely change to a more energy efficient system. If it's a motor, from standard motor, for example, to energy efficient motor. The last one is use of renewable. For example, this building, part of the systems of the energy consumption can be supplied from a renewable source. That's the way we can also have opportunity for energy saving within your buildings. Another one chapter is identifying how can you identify energy efficiency options. There are two ways you can identify energy efficiency options. During a design and when the building is in operation. But when you are designing, it's where we can get the most opportunity of energy efficiency within the buildings, because we consider all the passive and active parameters of the buildings. So within the design, we consider the buildings, the materials, the orientation, and natural parameters of the climate. For example, the natural lights that's within a particular location. But when a building already exists, built, it's all you can consider the passive parameter, which are your equipments and appliances within a building. And a little bit of the building materials. So within the design stage, how can you can attain your energy efficiency? Through simulations and consider all the parameters of energy, you can know how your building will perform. So they start with the simulation and they know exactly what the parameters we want to attain. And also how which equipment are you going to use within a building. And then you select the energy efficiency equipment. This is one of the ways within the design stage you can use. But after installation, the only way you can do is assessing your performance and they look at the areas where you can improve the energy. That's why through energy auditing that I've already explained. So how the audit is being performed. First, you identify where energy is being used. You identify your major energy consumers within your buildings. If you identify your energy consumers within your building, it's the area when you mostly concentrate and you can improve your energy performance. Also, you need to know your energy balance within your building. The energy balance within, you need to know where energy is, different systems that are using energy within your building. Also, assessment of the bills and the other stuff, that's assessment of the bills that a building is using can help you to know exactly how the building is consuming and also put your baseline and compare also to the previous consumptions. After that, you assess your equipment. That's what we say level 2. You go to equipment by equipment and process and look for the opportunities for improvement in terms of energy. So you do measurement and analysis. We check for the energy, where energy is being lost, and then you can look, depending on industry best practice, you may find a way to improve how equipment is performing in terms of energy, and that you can recommend where you can improve. Another is how you can optimize energy use for thermal comfort. There are two factors. There are external factors and internal factors. External factors, those are climatic factors. These they may affect your thermal comfort within a building. So temperature, humidity, airflow, solar radiation, all that. But internal factors, they are people, equipment, and lights. These are the ones that affect your thermal comfort. Remember that within a building, the most important thing is the thermal comfort and visual comfort within a building. So by controlling this parameter, also you may optimize how energy is being used within a building. So by external factor, we cannot control always. So normally when you assess your energy performance and you do assessment, you look at the internal factors, the equipment, people, and lights. So how do you do that? There's a passive strategy, like I said, and the active strategy. Passive strategy, it includes parameters that are from design stage. But active strategies, these are the equipments that are being installed after the building has been built. So it includes fans, cooling system, and etc. So as an auditor, we normally look at our experiences on the active strategies when the building is already in operation. This is the case study of the PSSF tower that the audit, for 2 audit we did in April 2023, together with innovators. That's here also. So it's a level 2 audit to assess the current energy use within PSSF. One of the tower in PSSF, there are 4 towers there. So one of them that we did an audit to look at the areas where there's energy, we can conserve energy, and how we can reduce the energy use index. So by doing the process that I told you of energy auditing, one of the findings we found that when we did the assessment of the bills were correct. So this is one of the procedures you do when you do energy audit. You assess the bills and check if the bills are correct or not, but also the bills can be used to know your index, that you can compare later if you are performing well or not. Also, one of the major consumers was heating, ventilation and AC systems. Mostly it was chillers and chiller pumps that produce more at approximately 60% of the energy use within the buildings. So these are the different equipment that we assessed. That was the monthly consumption for May and June. You see the chillers and pumps were approximately 60%. So when you know that after you assessing, then you can concentrate on the major energy consuming equipments. That's where you have a more potential of energy savings. So after assessment, using real-time monitors, we did an optimization of the chilling system, cooling system. So we did optimization of how chillers can be used, start and stop time, as well as reset chiller water reset systems. Because we found that most of the times they may use 2 or more chillers at the same time, where the demand is very low. At the same time, we also found that at night they are using more consumption of the cooling system, but there are no occupants because most of the tenants are office. That the office time is normally at 6 or 7. So they are using more energy while there are no occupants. So these were recommendations that we found after analyzing and assessing, and that we found that we can save more than 40 millions and 50 million something within a short period of time by just optimizing your chiller usage. But also the opportunity for renewables there. Even though the renewable normally they have a long payback period, but at least for a section of the building, you can reduce the payback and you can use the renewable energy source for the section of the building. Thank you.